Okay, Algebra 2 should be the 8th of April. We're doing Unit 3, Lessons 5, 6, and 7. So linear stuff again. We'll see inverses again. We're going to see piecewise functions. We're going to see systems. That was the big thing too. All right, so which of the following is the correct formula for the inverse? We already covered this, so I got to do is switch x with y. And then, put the y there. Solve for y. All right, so I'm going to add 15. And then to get rid of that 5/3, I'm going to use the reciprocal, 3/5. 3/5. Don't forget, we got to distribute. So over here they cancel. On this side, if I distribute, I'm going to get 3/5 x, and then 3/5 of 15. Use your calculator if you need to. That comes out to be 9, so we're looking at choice 1. All right. Piecewise, y-intercept, y-intercept, there it is again. Plug 0 in, what comes out? So that's 0 is where it splits apart, but you can see it says less than or equal to 0, less than or equal to, or equal to. So we're going to use that part. 4 times 0, take away 12 is -12. Choice 3. All right, which of these is the correct one? All right, so I got a piece of a line, another piece of a line. I'm just going to maybe just use slope to figure this out. So, how are we moving here? Up 1 over 2. I know the graph paper is small, but up 1 over 2, up 1 over 2. So this slope looks like a half to me. It's positive. This is another positive slope. This one's going up faster. Looks like I'm going from here to that point, up 3 over 1. Need a little bit more to verify it, but that looks like a slope of 3 to me. So I'm going to go with choice 2. There's the half slope, and then it switches and becomes 3. Right? All the other slopes are wrong on one end or the other, and it switches. They all switch at 2. You can tell it switches at 2. They all switch at 2, but this is choice 2. It's the correct one. All right, inverse. So we saw this formula on the previous lesson. So y minus y1 equals slope x minus x1. So what is the x-coordinate? The x-coordinate is 5, positive 5, and the y-coordinate would be a -3, -3. So there's the point that we got. Now they're asking me for the inverse. What do I got to do to get the inverse? To find the inverse, I got to take my x and y and switch them. So -3, 5 is what I'm looking for. -3, 5, which is choice D, not 4. Got a letter there. All right, and then this multiple choice, well, it's not multiple choice. Solve the following system. So this is what we call we like to do the elimination method. All right, so we're going to take maybe the second equation, and I want to get rid of the y's, maybe multiply by -2, because what's going to happen? I'm going to get 4x, positive 4x, minus 2y, and don't forget to distribute over here in -16. The first equation I'm leaving alone. And what happens? The y's cancel. I get 9x equal to -9. Divide by 9. Get x equals -1. Now to solve a system, you got to get y too. So take either one of these equations. I'll take the first one. Plug the answer in. I get -5 plus 2y equals 7. Add 5 to both sides. I get 12. Divide by 2. I'm getting 6. So there's x, there's y. But the big thing that we did, the big type of question we had was this. Hopefully you remember this. Had it on the midterm exam. A lot of you did pretty well with this question on the midterm exam, so I'm hoping people remember this one. This one's particularly hard. I did it on scrap paper first, so I know that I'm going to tackle z. Z would be the one to get rid of. If you want to go after y, that gets messy. I did that. X looks like it's going to be messy, but I didn't do that one. But I'm going to get rid of z. I'm going to eliminate z. So I'm going to call this equation 1, equation 2, equation 3. So I'm going to triple. I'm going to take equation 1, multiply it through by -3. So I'd get -9 x, positive 15y, -6 z, and don't forget to distribute here. You get positive 15. All right, now I'm going to put equation 2 underneath it. Not changing that one. always want to add these cancel. That was the goal here. So I'm getting negative 4x 16y equal to 48. Okay. Now before we go any further, you got to say, oh wait, I got to get equation 3 involved. So how am I going to get 3? I want to get rid of the z again. I'm going to double it. I'm going to take equation 3, double it. So I'm going to get negative 4x positive 20y minus 6z equal to 80. 80, right? So I doubled all those numbers. I'm going to leave equation 2 alone. And again, what's happening? I'm getting rid of the z a second time. So I'm going to end up with just 1x plus 21y equal to, would be 113. 113. All right. So then, now I'm going to look at this. I'm down to 2, kind of like on that previous problem, problem 5. I got two variables. I think I'll get rid of x by multiplying this one all through by 4. Multiply it by 4. So 4 times x gives me 4x. Putting it over here. 4 times 21, 84. Positive 84y. 4 times 113, I think we'll bust out the calculator now. 113 times 4 gives me 452. 452. Now, why did I do that? So I can eliminate x now. If you add this up, you get exactly 100y. And over here, if you add those up, you get exactly 500. So up, divide by 100. Y is 5. All right. You might recall, we're not done. I got to back substitute. So I'm going to go back here because I got room. All right, I'm going to find x now. So x plus 21 times 5, I know what y is equal to 113. 5 times 21, what is that? 105? Yeah, 105 equals 113. Subtract 105. I'm going to get 8. All right, so I got y, I got x, I got x, I got y. I'm looking for z. Pick any one of the ones in the beginning. So I don't know, I'll pick the first one. So we got 3x plus 5y plus 2z equal to negative 5. I got x is 8, so that's going to become 24. I know this is 5, that's going to become 25. 2z equal to negative 5. So this gives me 49. Okay. Hope I'm doing this right. Minus 49. Minus 49. 2z equals negative 54? I did this earlier. I don't remember getting these numbers. I must have made a mistake. Put 8 in there, you get 24. Put 5 in there. Get that. I definitely got these right. Copy it down right? Of course. There's a negative there. A negative. So this was only 1, not 49. Negative 1. Much easier. Add 1 to both sides. 2z equals negative 4. Divide by 2. Divide by 2. Z is equal to negative 2. What a pain, right? But anyway, we got the answer. Easy to make a mistake. The one you got is a little bit easier. This is a tough one, but I put as an example. All right, this last question. Where would these two graphs intersect? This and its inverse. So first I got to find the inverse. So x and y are switching places. I'm going to take away 4. And then multiply both sides by the reciprocal, which is 2. 2 over 1 are just 2. So I get 2x minus 8 minus 8 equal to y. So there's the inverse. Here's the original. Where do they meet? You could do it on graph paper. I'll show you at the end on the graphic calculator, but let's just solve it algebraically. Set them equal. When is 1/2 x plus 4 equal to its inverse, 2x minus 8? So I like to get rid of my fractions, so I'm going to double everything. 2 times 1/2 is just 1x. 2 times 4 is 8. 2 times 2 is 4. 2 times negative 8 is negative 16. And now solve this for x. Subtract 1x. And let's add 16. So I'm getting 24 equal to 3x divided by 3. X is 8. Now we're not quite done because you're supposed to find y. Plug this back into either one of the original ones. I'm going to tell you y has to be 8 also. And I know this because they're inverses. So the answer's got to be 8, 8, because it had to be either like 8, 8 or 6, 6 or 5, 5. They have to be points that when I switch them, they're in the same spot. So if x is 8, y has got to be 8. There's the solution. Real quick though, let's put it on a calculator. If I'm lucky, maybe I already got it in there. Yes, I do, because I did it ahead of time. So I put the original equation in, the inverse in. I also put in y equals x, and I made it a thick line. So if I hit zoom 6, here's the original equation. Here comes the inverse. There's their meeting point, and this is what they call the line of reflection. That if you took this and reflected over, you get the inverse. And where do they meet? At 8, 8. But they had to meet, like I said, either at 8, 8 or 5, 5 or 0, 0 or negative 3, negative 3. That's the only place they could meet. Okay. So you got classwork to do now. A few multiple choice questions. You're going to show me, just tell me the answers. Number 5, you're going to have to show some work. 6 is the one you're going to have to show the most amount of work. You know, and I think on this one, you could either get x, eliminate x, or eliminate y, or eliminate z. The numbers are much smaller. It should be a little bit easier. And then this last one's just like the one I did. So show a little bit of work. If you got graph paper, you know, if you can print this out, you want to show me graphically, that's fine. But algebraically, it's pretty quick also. All right. Good luck. Stay safe.